Welcome to Concept 23A Teacher Talk video. In exercises 1 and 2, the polygons are similar. It's telling you that the polygons are similar. I always like to double check. So as we're looking, we see in the rectangles there, we've got all right angles. We know similar polygons have what? Congruent angles. And what sides? Proportional sides. So we need to make sure, we need to find the value of x. So to find the value of x, we are going to use those side lengths. Remember that we're going from rectangle to rectangle. We need to make sure we are matching up the corresponding sides from fraction numerator to fraction numerator, fraction denominator to fraction denominator. So we got 3 over 2. I drew my arrow. So I went from the larger to the smaller. So that means I needed to do that on the second side, set of sides, 7 and x. So what number is going to go on the numerator? You guessed it, 7. X is then going to go on the denominator. Hopefully you remember from, I think, 2 videos ago when we reviewed our ratio and proportions. We now have 2 ratios set equal to each other. We call it a proportion. And we need to solve the proportion for x. Everyone's favorite. You remember it from way back when, elementary school. You need to cross multiply. You're multiplying cross numerator of the left fraction by the denominator of the right fraction. So I'm going to have 7 times 2 gives me 14, and 3 times x, 3x. From here, we've got an algebra 1 equation. Got to isolate the variable. I got to get x all by itself. It's got a 3 multiplying, so we have to undo the multiplication by dividing. 14 divided by 3. It's not a nice number. It's got some decimals. Comes out to 4.6 repeating. I put the bar over top just to show that it is repeating. So we need to do that same thing for number 2. Find the value of x. It's telling us that they're similar. We can see in the picture that the 2 triangles are also similar with their congruent angle markings. I like to use different colors and go through and mark over those congruent markings. So because we need to make sure we are using the correct corresponding sides. So as you'll see here, I've gone through, and then I go to circle. So I see that x in the smaller triangle is between the 2 angles that are red and green. So in my larger triangle, I'm going to do that same thing. 25 is the number between those 2 angles. So I did that with all of my sides, so now I know what I can match up on the numerators and the denominators of each fraction. Trying to find x, so I gotta have x somewhere. X, if I choose to use it on the numerator, the number corresponding with it, 25, has got to go on the denominator. And we set it equal to another ratio. Choose whatever you like. If you want to choose the blue circles or the black circles. Here I chose the blue circles, so I need to use the number from the smaller triangle because I used x on the left fraction. I used x from the smaller triangle, so I must use the smaller triangle's information for the next fraction. So therefore, 30 must go on the denominator. From there, cross multiply, solve your algebra equation. We end up getting 30x equals 300, divided by 30, and x equals 10. Number 3, the following polygons are similar. Write a similarity statement for the 2 figures. In order to write this similarity statement, we need to know which side lengths are proportional. Therefore, the corresponding side lengths, they must be proportional to be similar from the pre-image to the image. So first I'm going to look at 7 and 10.5. I chose those 2 because I noticed that 7 is the 2 on the left and the right, and 10.5 is on the left and the right. So those 2 have to correspond. So when I divide 7 by 10.5, I'm going to get 0.6 repeating. Now I need to check my other side lengths to see which way I need to write my similarity statement. So let's just check 4 and 6. 4 divided by 6, plug in your calculator, you get 0.6. So I know I need to go starting from W up to X, then Y, then Z in the first polygon, and from S to T to U to V. Make sure you have your tilde in there to show that they are similar. So Polygon WXYZ is similar to polygon STUV. Number 4. Are the following figures similar? Explain. In order for two figures to be similar, their corresponding side lengths must be proportional, and we must know that the angles are congruent. I don't have any information in this picture or in the instructions about angles, so I know I need to look at the side lengths. You may need to slow down the video or definitely pause it because I do some erasing when I do this next part. So I'm going to color code the side lengths I am checking to see if they are proportional. So in the first one, I'm going to look at 12 and 18. So 12 divided by 18, is that equal to, and then just take two other side lengths. Make sure you're using the numerator from the same triangle you did in the first fraction. So is that equal to 5 over 10? No, we know 5 over 10 is 1/2. We can already stop. We know that those two triangles will not be similar. So nope. All right, so I did some erasing. Now this time I'm going to look at, again, 12 and 18, but I need to reverse the other side. So is 12 over 18 equal to 8 over 10? Plug in your calculator, you find that it is. But then you have to check the last one, 5 and 12. Is that equal to 5 over 12? And unfortunately, it does not work. So I'm going to keep on with this pattern, making sure that I have captured every possible triangle there is. So here I'm looking at 12 over 10. Is that equal to 5 over 18? There's no way. 12 over 10, that's bigger than 1. That's bigger than 1 whole. 5/18, not even close to a half. So nope, nah. All right, so check 12 over 10 again, but this time we're going to look at 5 over 12. Nope, still no. And the last possible triangles we have, let's check 12 over 12. Is that equal to 5 over 10? 1 is not equal to 1/2. Nope. And erase. The last one we've got is 12 over 12 equal to 5 over 18. And again, no. So the figures, the two triangles, are not similar here. Why are they not similar? They're not similar because the corresponding side lengths are not proportional. We have no corresponding proportional sides.